Okay. Good morning, all. From last lecture, we are discussing about the copper alloys, and in that, we have finished the discussion related to the brasses. Now, after seeing the different types of the brasses, there is one more term, that is the season cracking of the brasses. What is the meaning of the season cracking? This is very short point. Means what is the meaning of season cracking? Why it occurs? And how it can be avoided? That you have to write in this point. Now, first, we will discuss what is the meaning of the season cracking. Now, first of all, um, okay. Now, first you have to understand that both types of the brasses, that is alpha type and alpha beta type of brasses, are susceptible for this defect termed as the season cracking. Now, what is the meaning of the season cracking? Season cracking is formation of the crack whenever we are doing the cold working operations on the any component. Whenever we are doing the cold working operations on any component, what will happen? Some internal stresses will get created in that component, and when that component consisting of internal stresses when subjected to the we can say that the corrosive environment, then there will be intergranular corrosion in the sense the grain boundary will get corroded. Grain boundary in that microstructure present, it will get corroded. Okay, I will repeat it. Sorry for disturbance. I will repeat it. What is the meaning of the season cracking? In the alpha type or alpha beta type of the process, if due to the cold working operations carried out, you can refer the second point, that is internal stresses are developed due to the cold working operations like pressing, deep drying operations, or any similar kind of cold working operations. Internal stresses will get developed in that component, and when these components in which already some internal stresses are there, when it is subjected or when it faces a corrosive environment, then the corrosion will increase. Means its tendency to get corroded will be more due to the internal stresses present in it, and its corrosion will occur due to the intergranular corrosion type. Now, what is the meaning of intergranular corrosion? Intergranular corrosion means its boundaries will get corroded initially. Okay, boundaries will get corroded, and that grains will get removed. Whichever microstructures will be there, its boundary will get corroded and the grain will get released, and loss of material will occur. This type of corrosion will be termed as intergranular corrosion, and due to this intergranular corrosion and internal stresses present in that component, the some crack will be formed, and this due to this crack, failure of that component will occur. This type of cracking will be termed as the season cracking of the brasses. Means due to the internal stresses present, due to performance of various cold working operations, and when it is subjected to the corrosive environment, it will get corroded by intergranular corrosion process, and due to that crack formation will take place, and that due to that crack formation, the component will get failed whenever you are using it in the actual practical service. Uh, this type of cracking will be termed as season cracking of the brasses. Now, how to avoid this season cracking of the brasses? That will be our next point. So, to avoid this season cracking of the brasses, what you have to do? You have to perform the heat treatment process on it. That is the annealing heat treatment process will be there. Uh, Now, in this, what exactly we are doing in this annealing heat treatment process? We are taking that component in which we are having some internal stresses. Okay, that internal stresses component having internal stresses in it due to the cold working operation that we are taking, and we are heating that component in the furnace at approximately 280 degrees Celsius to 300 degrees Celsius, and due to this, and after this heating we are cooling it. Okay, Now, what happens due to this process, whichever internal stresses are present in that component, that internal stresses will get removed. This process is termed as the annealing process. Okay, we are taking that component, we are heating it at 280 degrees Celsius to 300 degrees Celsius, and after heating it, we are doing the slow cooling of that component. It may be done in the air medium, or the sometimes you can do the cooling in the furnace also. This process, what will happen that whichever internal stresses are there, it will get removed. So this, in this way, by performing the annealing process in this temperature range, you can remove the internal stresses, and whenever internal stresses are absent in that component, then its tendency to get subjected to the season cracking will be very much less. Now, so, how to determine whether that component is susceptible for the season cracking, means whether season cracking will occur or not whenever you are using that component in your practical life. It can be detected by taking that component, and you can immerse that component directly in the mixture of 1% mercurous nitrate and 1% nitric acid. You have to take this mixture in the water, 1% mercurous nitrate and 1% nitric acid in water, and you have to dip the component in this mixture for approximately 15 minutes. And if the formation of crack takes place in that component, means that particular component may be susceptible for the season cracking, then you have to perform the annealing process on it to avoid that season cracking. Now, in general, whenever percentage of the zinc is very high, that is more than 20%, then that kind of the brasses are susceptible for the season cracking. Means in that component, chances of occurring of season cracking is very high. Whenever percentage of the zinc is more than 20%, and when percentage of the zinc is less than the 20%, then chances of occurring season cracking is very low, or it may not occur in that type of brasses. Okay, means whenever high percentage of zinc is there, then chances of season crackings are more, in short. So this is the point, that is the season cracking of the brasses. And in this we have discussed why this season, what is the meaning of the season cracking, what is the meaning of season cracking, then how it is occurring, means due to internal stresses and internal granular corrosion, cracking will occur, and how it can be avoided by performing the annealing process on its component, how it can be tested, that is susceptibility to the season cracking for a particular component, by immersing that component in the mixture of 1% mercurous nitrate and 1% nitric acid in the water for 15 minutes. And which brasses are more susceptible, means high zinc brasses, in short, means containing brasses containing more than 20% zinc are more susceptible for season cracking. And whenever zinc percentage is less, chances of this season crackings are very much less, or you can say that it does not occurs in the uh, brasses containing zinc less than 20%. Now after the, so in this way we have completed this part up to the from the copper alloys we have completed the part, that is first type, brasses. Then the next type in this copper alloy is bronzes. Okay. Now, what is the meaning of the bronzes? Bronzes that already I have discussed. I will repeat it. Bronzes are the alloys of copper containing element other than the zinc. Alloying element will be other than zinc, and depending on the presence of that alloying element, that bronze name will be determined. Means suppose here, if alloying element is aluminium, then it will be aluminium bronze. If alloying element is tin, it will be tin bronze. If alloying element is the silicon, it will be silicon bronze. If alloying element is the beryllium, it will be beryllium bronze. Okay. So in our syllabus, these four types of bronzes are there, that we will discuss one by one. uh, from that, the first type is the aluminium bronzes. Now, these aluminium bronzes are alloys of copper and aluminium. Okay, this copper will be your base metal or parent metal, and aluminium will be your alloying element. Now whichever commercial alloys we are using, means alloys which we are using in our practical life, it contains approximately 4 to 11% aluminium, and some other alloying elements may be there according to the needed properties, like if suppose if you want to improve its tensile strength, then you can add iron or manganese like this, or some other properties. If you want to improve, then you can add nickel, silicon like this. Means in general, aluminium percentage will be in the range 4 to 11%, and some other alloying elements may be present in small amount, and that alloying elements may be iron, manganese, nickel, silicon, depending on desired properties. Now before going for the actual properties, first we will discuss related to the uh, its equilibrium diagram. Okay, so this is the equilibrium diagram for copper and aluminium. Okay, in examination they are not going to ask you the equilibrium, only one equilibrium diagram will be asked, that is the first one, copper and zinc's equilibrium diagram will be asked. These diagrams from here for the bronzes, whichever equilibrium diagrams are there, they are not going to ask you. This is for your reference only, and which things they are going to ask you related to the composition properties and their applications. Only these things they are going to ask you in these bronzes. They are not going to ask you reference. Now maximum solubility here, as this is the alloy of copper and aluminium. Copper is base metal, aluminium will be alloying element. Here you can see here, please observe the diagram also while reading these points. Maximum solubility of the aluminium is in the copper. It means this point. Okay, you can see that, refer this line here. Maximum solubility of the copper in the sorry, of the aluminium in the copper will be, observe this particular point, at 565 degrees Celsius it will be 9.4. Okay, maximum solubility of aluminium in the copper, it will be referred by this line, and at this particular point solubility will be maximum at 565 degrees Celsius, it will be 9.4. And next thing which you have to remember here, that at this point, okay, this is the eutectoid transformation point, and here percentage of the aluminium is 11.8. This point is 9.4, and this is 11.8% aluminium. And at this point eutectoid transformation will occur. Eutectoid transformations means one solid, this beta phase, from this beta phase two different solids will get formed. Okay, alpha plus this gamma phase, this beta will get transformed to the mixture of two different solids. In this way, this is the eutectoid transformation. Okay, just these two or three points you have to write here. That is, maximum solubility of the aluminium in the copper it will be at this temperature, that is 565, and it is 9.4. And eutectoid transformation or eutectoid composition is 11.8% aluminium. And at this point the eutectoid transformation will occur, means this beta phase will get decomposed, and it forms the mixture of two phases, that is alpha and gamma phase. And up to this approximately 9.4% aluminium, only single phase will be there. Okay, only single phase, that is alpha phase will be there. Now after this point already I have discussed, that is its aluminium percentage in the commercial alloys is 4 to 11%, and some other alloying elements may be there depending on our need. So this is the explanation or points which you have to remember related to the equilibrium diagram. Just you have to write the maximum solubility and whichever important transformation is there, that is Utica transformation here in this case, that temperature and that particular composition you have to remember. Temperature will is 565 for that Utica transformation. Composition will be 11.8, and maximum solubility will be also at this temperature 565, and composition will be 9.4% aluminum at this point. Now, related to the properties, these aluminum bronzes will be having very good strength, and also it will give you ductility with some toughness, and it is having very good bearing properties. Now here bearing properties means it can carry the large amount of the load without any deformation. That will be termed as the good bearing properties. Then it is also having good resistance to the corrosion and good resistance to the fatigue also. And then good resistance to the fatigue means it can carry the different amount of the cyclic loadings conditions also. Then this is very important property, that is these aluminum bronzes are very lustrous, and their color will be finest in the all copper alloys, means their color or their appearance will be very similar to the gold, a very attractive color they will have. And that's why these are also termed as imitation gold. Okay, imitation golds. Sometimes they may ask you questions, instead of writing the aluminum bronze, they will write the composition properties and applications of the imitation gold. This imitation gold is nothing but the aluminum bronze. Because of their lustrous appearance, or you can say that the finest or very attractive color, these are termed as the imitation gold, because their appearance or look is very much similar to the gold only. That's why this name is given. Now after seeing these properties, we have to discuss related to the applications. Now while seeing the applications here, according to their types, we are going to discuss the applications. Now here two types of aluminum bronzes are there, that is single phase aluminum bronze and dual phase or two phase aluminum bronzes. Now uh, you can say that from the equilibrium diagram here itself, here we are having single phase approximately some 9.3 or 9.4% of the aluminum only single phase. Now the commercial alloys of this aluminum bronzes, whenever composition is in the range 4 to 7% aluminum, completely single phase will be there. And 8 to 11%, up to this we are considering 11 or 11.5. Here you can say that two phases will be there. Here only single phase is there, and here we are having two phases. So this is single phase aluminum bronze within this composition, and after this is the two phase or dual phase aluminum bronzes. Now depending on these phases, these two types are there, and only depending on these phases we are going to decide their properties and application. Now single phase aluminum bronzes, here we can perform the, as they are having only single phase, that is alpha phase, they will have very high amount of ductility. That's why we can perform cold working processes very easily on single phase aluminum bronze. And due to this, their applications are these alloys can be used in the jewelries. Okay, jewelry is not made up of gold, but it looks exactly like the gold, and that will be the your imitation gold. Means single phase aluminum bronze, that is used for manufacturing of the different jewelries. Then cigarette cases are there, some attractive cases are there, that are made up of single phase aluminum bronzes. And different types of the heat exchangers and different components which are used in the chemical plants that are manufactured with the help of this single phase aluminum bronzes. Then dual phase aluminum bronzes, it will contain the higher amount of the aluminum. Due to the higher amount, whenever it crosses that 9.3 or 9.4%, two phases will appear there. And due to this two phases, that second phase First is the alpha phase, and due to that second phase gamma, here we will find that it is having a better tensile strength as compared to the single phase aluminum bronze. Uh, and now have to perform on these dual phase aluminum bronzes. You have to use some hot working operations to give them desired shape and size, and their applications are these can be used for manufacturing of different pump castings. Then wall fittings are there, different propellers we are using that can be manufactured with the help of these uh, dual phase aluminum bronzes. Then cylinder heads, gears, different kinds of the dies, bearings, and then spark plug bodies, and some the electrical contact materials which we are using that are made up of this dual phase aluminum bronzes only. Okay. So this is the first kind of the bronze, first type of the bronze, that is the aluminum bronze. In this we have discussed its composition. It is the Okay. It is alloy of copper and aluminum. Then approximately it contains 4 to 11% aluminum. Whichever commercial alloys, there may be more amount of the aluminum, but whichever commercial alloys as we are using in the practical life that are made up of, or it consists of 4 to 11% aluminum only. Depending on this percentage of the aluminum, two types of these aluminum bronzes are there, that is single phase and dual phase. 4 to 7% aluminum, then it will be termed as single phase, and whenever amount is more than that 8%, it will be termed as two phase or dual phase aluminum bronze, and depending on its property will get changed, and its applications will also get changed. Then this is the equilibrium diagram for your reference. Just you have to remember that the maximum solubility of aluminum in the copper is at this point, that is 565 degrees Celsius temperature, and it is 9.4%. And at this particular point, that is at 11.8% aluminum, eutectoid transformation will occur from this beta phase. Beta phase will get decomposed to form mixture of alpha phase and gamma phase. After discussing this aluminum bronze, then next type is the tin bronze. This tin bronze is nothing but this tin bronze. It is now alloy of the copper and the tin. Copper will be base metal and tin is the alloying element. Now, here I will explain first related to this equilibrium diagram. Just you have to explain few temperature points and transformations of it. Now, solubility. These lines will indicate the solubility. Okay, alpha phase is there, means all tin will get dissolved in that copper. Now, at this particular point, okay, at this point, solubility of the tin in the copper is 13.5%. Okay, at this point, this temperature is 798 degrees Celsius, and at this particular point, the solubility of tin in the copper is 13.5% at 798 degrees Celsius. At this point, solubility of tin in copper is 13.5%, and this temperature is 798. And when as temperature falls again, okay, as temperature falls again, its solubility will, you can see that the solubility is increasing. Solubility of tin in the copper increases, and at this point, this 568 degrees Celsius, it becomes 15.8. Okay, 15.8% tin will get dissolved or will get soluble, completely soluble in that copper at this 568%. Then it remains, solubility will remain constant up to 520 degrees Celsius temperature. Okay, you can also read for your reference. Here I have written the same things. Okay, at 798 degrees Celsius, solubility of tin in the copper is 13.5%, It goes, as temperature falls, it goes on increasing and it becomes 15.8 at 568 degrees Celsius, and it remains constant up to 520 degrees Celsius. And further, it will decrease as temperature falls. Solubility will also decrease and it becomes 11% at approximately 350 degrees Celsius. And as temperature goes on decreasing, okay, it will become 1% at room temperature. This line does not indicate the room temperature. At room temperature, it will come somewhere here, approximately 1%, okay, at room temperature. So this is related to the solubility of the tin in the copper at different temperatures. Here at 798, it is 13.5%. Then it will become 15.8% at 568 degrees Celsius. Then at this point, it will remain constant from 568 to 520. Then at 350 degrees Celsius, it will become 11%, and at a room temperature, it will be only 1%. Now, okay, now here you can see clearly that these are some transformations are occurring at these temperature lines. Okay, here this uh, whichever beta phase is forming, here gamma phase is forming, delta phase is forming, like this different phases are there. Now here you can clearly understand that a peritectic transformation reaction occurs. Okay, peritectic transformation reaction occurs at 798 degrees Celsius. Okay, whichever alloys are there from this point, this is the 13.5%, and up to this point, that is exactly, you can say that approximately or exactly 25%. Okay, 13.5 to from this point to this point, mixture of this alpha and liquid. Okay, peritectic transformation means mixture of one liquid and one solid will combine together to form a new solid, that will be termed as the peritectic transformation reaction. And in this diagram, peritectic transformation reaction is occurring over the range of this composition over this horizontal line. Okay, and this temperature will be 798 degrees Celsius. And if composition is in the range 13.5 to 25%, okay, to 25%, this reaction will occur before this point. Okay, not at this point, before this point composition you have to take, because at this particular point liquid is giving some mixture of the solids, it will be another transformation. You can say that it is a eutectic transformation. Okay, liquid is transforming different solids at this particular point, and this is eutectic transformation. But before this point, okay, all the transformations from this 13.5 to before this eutectic transformation points, all alloys will get subjected to the peritectic transformation, means solid plus liquid, this alpha phase and this liquid phase will get transformed to beta phase. Okay, here mixture of beta plus liquid will be there. Okay, here alpha plus liquid, in this blank portion here beta plus liquid will be there, beta plus liquid will be there, and in this portion gamma plus liquid will be there, this third portion. Okay, they have kept it blank here, beta plus liquid, gamma plus liquid. Just try to understand that this, they are not going to ask you this diagram in the examination. Just try to understand which transformations are occurring. Means at this horizontal line. Okay, at this particular temperature peridotite transformation will occur, and this alpha plus L, or that is the solid phase plus liquid phase, will combine and they will form the beta phase. Okay, now as temperature falls, these phases will get break, this beta will get break to form this gamma, gamma will break to get formation of this delta. Like this different transformations will occur as temperature falls. Now we will come towards just what you have to remember in this diagram, that is maximum this 798 degrees Celsius. Here solubility of tin in copper is 13.5. Then maximum solubility will be 15.8% at 568 degrees Celsius. These 2 points you have to remember, and it will fall up to 1% at the room temperature. Now what related to the properties, now these tin bronzes, they are having very good corrosion resistance and they are having very good bearing properties in the sense they can carry large amount of the load without any kind of the breakage, or you can see the deformation. Now these tin bronzes will show you very good ductility and malleability whenever percentage of the tin is up to 8%, and when the tin amount goes beyond that 8%, there in that case or that particular bronzes will provide you very good fluidity. Okay, somewhat ductility will be lesser, but they will provide you very good fluidity, and as fluidity is more and ductility is little less, what will happen? Now you have to use the different casting operations here. Then you can add some other alloying elements in this case also. Initially or basically tin bronzes are alloys of copper and tin. Copper will be base metal and tin as the alloying element, but you can add some more elements like lead to improve certain properties like machinability, or if you suppose you want to improve its bearing properties, that is load carrying capacity, then you can add the lead element in it. So these are the properties of these tin bronzes. Then these tin bronzes, okay, these tin bronzes are categorized in the four groups. That is four groups. In that first group is the alloys which contains the tin up to 8%, then alloys which contains tin 8 to 12%, then the alloys or tin bronzes containing 12 to 20% tin, and then tin bronzes containing 20 to 25% tin. Now depending on this percentage of the tin, there will be variation in their properties. We will see one by one. Now the first category, that is alloys up to 8% tin, these are having only single phase structure. Okay, up to 8% tin, single phase structure will be there. And in this single phase structure, due to this single phase structure, what will happen on their solubility, sorry, and their ductility and malleability will be highest among all these four types. Their ductility will be maximum, and along with this they will show you very good corrosion resistance also. Now due to these properties, they are they can be converted in the form of sheets, wires, or they can also be used in the form of the coins also. Okay, now in practical life, that part in the next slides I have added few types. In that also we will going to see, but these alloys up to 8% tin, these are used for manufacturing of the coins. Okay, different coins are manufactured with the help of this alloys which are having less than 8% tin amount. Then alloys which are having 8 to 12% of tin. Okay, here they will have some better 8 to 12% in, and they will provide you the better tensile strength along with the better bearing properties. Due to this, these alloys are used for manufacturing of the pumps, then different types of the gears, then different types of the heavy load bearings. Due to their better tensile strength and better bearing properties, that is better load carrying capacity, alloys having tin in the range 8 to 12%, they are used for manufacturing of the different types of the pumps, gears, different types of the bearings required for carrying the higher, more heavy loads. Okay, that will be manufactured with help of these alloys containing 8 to 12% tin. Then again, when again we are increasing the amount of the tin when it goes about 12%, then these are having the you can say that the highest amount of the load carrying capacity will be there in these kind of the alloys containing 12 to 20% tin. That's why these alloys are specifically used for or specially used for manufacturing of bearings only. Okay, whichever bronze bearings are there, that is tin bronze bearings will be there, it will contain 12 to 20% tin, because they will carry the high amount of load or they are having excellent bearing properties. Then the alloys containing 20 to 25% tin, and these are a little bit hard and brittle in nature. Okay, these will be hardest and somewhat brittle in the nature, and they will give you whenever there is any impact on it or uh, light force on it, they will give you the ringing sound will be there. Due to this, these alloys containing tin 20 to 25%, these are used in the manufacturing of the different kinds of the bells. Okay, different kinds of the bells to get the alerts, that all are manufactured by these bronzes containing 20 to 25% tin only. Okay, so this is the categorization. According to the categories, their properties will get changed, and depending on their properties, their applications also get changed. Now, some practically used bronzes are there. Practically used tin bronzes are there. Some 5 to 6 types are there that I have collected here. It is applications with some specific types. In that, the first type will be, these are the some specific types of these bronzes. First type is the coinage bronze. In bracket, I have written its composition. It will contain 5% tin, 1% zinc will be there, and remaining amount of the copper will be there. And these are used for manufacturing of the different types of the coins. This is the coinage bronze, 5% tin, 1% zinc, remaining amount of the copper, used for manufacturing of the coins. Then the next is the gunmetal. Now it contains 10% tin, 2% zinc, and remaining will be copper. And these are as why these are termed as gunmetals. Largely, these are used for manufacturing of the gun barrels. Okay, manufacturing of the gun barrels. That's why in or these are used for manufacturing of the different ordnance parts. Okay, for manufacturing of the different defense equipments, you can say that. That's why it is termed as the gunmetal. These are also used for manufacturing of the gears and bearings also, or different types of the wall bodies also manufactured with the help of this gunmetal. Specifically, especially these are used for manufacturing of the gun barrels and different components in the which you can say that different components in the defense equipments that are manufactured with the help of this gunmetal. The next type is the phosphor bronze. Now this phosphor bronze, the phosphor bronze, here phosphor bronze, it is the alloy of copper, tin, and phosphorus. These are termed as the phosphor bronze. And this phosphor bronze has two types, that is wrought phosphorus bronze and cast phosphor bronze. Depending on their composition only, these classification is done. Now composition I have mentioned in front of its name. This wrought phosphor bronze, it is having 2.5 to 8% tin and 0.1 to 0.35% phosphorus. Phosphorus amount will be lesser in this, and these are used for manufacturing the springs, then different kinds of the wire gauges, wire brushes, or electrical contact materials that can be manufactured with the help of this wrought phosphor bronzes. Then cast phosphor bronzes, depend these will be having 5 to 13% tin, and phosphorus will be at the little bit higher side, that is 0.3 to 1%. These are used for manufacturing of the different types of the gears, different types of the bushings or slide walls are there that are manufactured with the help of these bronzes, cast phosphor bronzes. Okay. After this, we will move towards the next type. These are some specific applications are there. It is statuary bronze. These are generally, you can remember, it's used. That is, these are used in the statues. Whichever brownish black color is there, components are there, brownish black color components, which are termed as the patina in the different kinds of the statues. These are made up with only this statuary bronze. And here you can say that whichever composition we have discussed here, just you have to add 2% lead. Okay, which composition we have discussed for gunmetal. Okay, same composition will be there, 10% tin, 2% zinc. In this, just you have to add 2% of the lead. In gunmetal, if you add 2% lead, it will get transformed to the statuary bronze. Okay, and these can be used in the different kinds of the statues. Depending on that, only the statuary bronze name is given. In the gunmetal composition, that is 10% tin, 2% zinc, you have to add the lead only. This lead will improve the machinability. This lead will improve the machinability of that particular bronze. Then some compositions are there, some bronzes are there depending on the compositions of the alloying elements. Here 80 10 10 bronze. Okay, 80 10 10 bronze. This 80% will be copper, 10% approximately 10%, that is 9. In this range they will vary, 9 to 11% tin and 8 to 11% lead. You can say that 80% copper, 10% tin and 10% lead. Okay, this is 80 10 10. This is the lead, this is tin, and this is the copper. And these are used for manufacturing of the high speed, heavy pressure bearings and bushings. Okay, or you can simply write the manufacturing of the bearings also. 80 10 10, that is 80% copper, 10% tin and 10% lead. And again 85 5 5 5 bronze. This is also termed as the ounce metal. Ounce metal. Now here 85% will be copper, 5% will be 5% tin, 5% lead, and 5% zinc. Okay, and this will be termed as the ounce metal, and these are used widely used for manufacturing of different kinds of the bearings. Then different kinds of the low pressure valves are there, then different taps, pipe fittings, then different types of the gears which are smaller in the size, and different ornamental fixtures. All these can be manufactured with the help of this metal. These, it will be manufactured with the help of this ounce metal. Okay, so in this way, these tin bronzes, we have completed the discussion related to this tin bronzes. Okay, it's different composition, its classification, and its some different properties and applications. Now the next type of bronze is the beryllium bronze. Okay, beryllium bronzes are there. Now this is the equilibrium diagram for the beryllium bronzes. Just you have to remember, now beryllium bronzes, this is the alloy of copper and beryllium as the alloying element. Now maximum in the commercial beryllium bronzes, it contains approximately 2.1%, 1.5 to 2.1% of the beryllium will be there. Now, which points are important? This particular point, it is the point which is having maximum solubility. That is, the structure will be only single phase. That is 2.1%. Solubility of the beryllium is 2.1% at 864 degrees Celsius, and it decreases at 10. as temperature is decreasing. Okay. Now, one more important point is here, that is the alloy beryllium bronzes containing 1.5 to 2% beryllium. They exhibit the phenomenon of precipitation hardening. Okay, these are having the phenomenon of the precipitation hardening. Now, there is one separate article related to this precipitation hardening in the next type. We will discuss there what is the meaning of this precipitation hardening. Just try to remember that due to this process, hardness of that particular alloy increases. Okay, whichever what exact phenomenon occurs, that different stages are there. It requires 1 hour lecture, and that we are going to conduct after 2 or 3 lectures only. In that we will see the different stages there. Just what you have to remember here, they are having, they shows the precipitation hardening, and due to this precipitation hardening they are having very high hardness also. Okay, bronzes mean bronzes, that is beryllium bronzes containing 1.5 to 2% of the beryllium means, and these alloy will provide you better tensile strength and hardness, and this tensile strength and hardness is due to only due to this process, that is precipitation hardening. It will improve the hardness and tensile strength. Now, their properties, and these beryllium bronzes will have very good corrosion resistance, very good fatigue resistance, then very good what you can say, that the resilience will be very high. Resilience means they will show you the elastic properties. Very high resilience means they will show you the very good elastic properties and very good bearing properties. High resilience means very good elastic properties, means they are regain its original shape and size after the applied load gets removed. That is the very good resilience. And good bearing properties means they are having ability to carry the high load. And then low elastic hysteresis. um, Hysteresis means the change, whichever amount, means the strain energy they can. Low elastic hysteresis means variation in the that strain energy, the actual required strain energy, or you can say that actual required that amount of energy that they can absorb will be very high. Whenever you are using it in the actual practice, very less changes will be there. That will be termed as the hysteresis. Then after that, they shows the non-sparking characteristics, means if you perform the machining operation on it, no spark will get created. Okay, if you perform any kind of the machining operation on it. These are some properties and some applications will be there. These are used for manufacturing of different kinds of the springs. Then diaphragms, flexible bellows are there, gears, bearings. You can say that depending on their properties only. That is, they're having very good bearing characteristics. That's why they are used for manufacturing the bearings. Then they are having very high resilience and very low elastic hysteresis. Due to that properties, these are used for manufacturing of the hammers, and used for manufacturing of the different kinds of the hammers. Okay, means while hammering, it should absorb the large amount of the energy. Okay, large amount of the energy will get absorbed during the hammering process. Then the next use is for, these are used for manufacturing of the electrical contact materials and molds for performing the forming process on different kinds of the plastics. Okay, so these are the beryllium bronzes. Then the next type or last type of the bronzes is the silicon bronzes. Okay, this is the silicon bronze. Silicon bronzes are the alloys of copper and silicon. Copper will be base metal and silicon will be the alloying element. Now, here their solubility, just maximum solubility of the silicon in the copper is 5.3% at 845 degrees Celsius, and it decreases up to 4% at the room temperature. Now, in actual practical life, whichever silicon bronzes we are using, their composition means copper will be there as a base metal, and silicon will be varies in the range 1 to 5.5%, 1 to 5.5% silicon, and remaining amount of the copper will be there. Now, and to increase some strength or some machinability, you can add manganese, iron, zinc elements. Or suppose if you want to improve its machinability, you can add the lead in it. Okay, depending on the properties needed, you can add other alloying elements, but principal alloying element will be silicon, and its composition will vary in the range 1 to 5.5%. Okay, and this point is very important. First point and third point you have to remember, or you have to write it compulsory. Third and fourth point. The second point is just for your information purpose, that is maximum solubility of silicon in copper is 5.3%, and it will be at 845 degrees Celsius. Okay, and it decreases to 4% at the room temperature. Then what about its properties? Depending on the composition only, different properties will be there. Now here, as you are using different alloying elements, uh, it is having different properties according to its composition. These are general properties. They are having very high resistance to the corrosion. They will show you very good tensile strength and very good toughness also. As we are adding manganese and iron, it will provide you tensile strength, and due to this lead, it will improve machinability and its toughness also. Then these silicon bronzes, you can do cold working operation on it, or you can do the hot working operation on it very easily, or sometimes you can use also casting operation on it also. Okay, to give the desired shape and size. Now, where these silicon bronzes are used, these are used for manufacturing of the high strength bolts, rivets, then springs, propeller shafts, and different types of the bells. Okay, for bells, you have to increase manufacturing the bells, you have to increase the amount of iron manganese elements. Okay, so that it will provide you the more strength. Okay, for manufacturing of the bolts, rivets, or springs, you have to add manganese iron along with the more amount of the lead also. So these are the silicon bronzes, its composition, properties, and application. And these silicon bronzes, their trade name means the manufacturers are not using the silicon bronzes name; they are using the names like Everdur, okay, Everdur or Herculi. These are the names for the silicon bronzes. In exam, they may mention you these names: that is Everdur and Herculi. Okay, Everdur and Herculi. This is the manufacturer's name, or you can say that these are the trade names which are used for the silicon bronzes, and different names are used by different manufacturers. Okay, these are nothing but the silicon bronzes only. Okay, in this way, in this lecture we have completed the different types of the bronzes also. Okay, okay, till this lecture we have completed the copper and copper alloys. In that copper alloys, we have discussed the brasses, different types of the brasses, and different types of the bronzes. Bronzes in this today's lecture only we have completed the bronzes. In this we have studied the aluminium bronzes, then tin bronzes, beryllium bronzes, and silicon bronzes, along with their composition, properties, and some specific applications. Remember this point for whichever these four types, and just that equilibrium diagrams are just for your reference purposes. Don't get confused how to remember these complicated diagrams. Just whichever points you have to remember, that only soluble for the maximum solubility point only I have shown that equilibrium diagrams. Okay, only just you have to remember the maximum solubility in all in here. For example, 2.1% will be maximum solubility at 864 degrees Celsius, like this. Okay, which important point is composition, properties, and their applications. Okay, in all kind of the bronzes. But for in case of that brass, that is the copper zinc equilibrium diagram, that diagram you have to remember along with phases and temperatures. Okay, in this way we have completed the all types of the bronzes in this lecture. Okay, I will stop here. Thank you for attending the lecture.